Now we will define the construction stages. So you can close this window, go in group. First thing we'll have to do is to assign all the nodes and elements here to the structure group by drag and drop. And now we will assign the construction stage. So you can see here the PDF, so CS1, CS2, CS3 and CS4 are the 4 construction stages. The element group and the boundary group associated with each step, the load groups also. Here you have the time, first step, the activation time, and some remark. So let's do that. So the method used actually is to generate all the construction stage and then to modify each construction stage separately. So click on generate. You can enter name. So CS for construction stage. Suffix, it will be 1, 2, 4 because we have 4 construction stages. You can enter 30 days for the duration, and additional step days 25. Click on add, and finally click on apply. So now you have the 4 construction stages, and we will have to modify them individually. So click on the first one, modify show. First let's delete the additional step here. For the duration of the first stage it will be 5 days. Here in the group list, so you have 3 tabs: element, boundary, load. So you have to go through these 3 steps for each construction stage. So first of all, as group, so age 0, click on add. Now go in the boundary tab, click on B group and click on add here. Finally go into the load tab, select DLBC1 and DLBC2. Here active date will be from the first day, so click on add and click on OK. So now you modify the first stage. Second stage, group list, so go in the boundary tab, E-whites 1, click on add here, then go in the load tab and DLBC3, active day 25 day, and click on add, click on OK. Now third stage, boundary E-whites 2, add, and load, it will be DLBC4, add, from 25 days. Okay, click on add, and finally for the next stage you will delete again this additional step. Duration 10,000, it's the life of the bridge. So boundary tab, E-whites 3, add, and for the load it will be the DLAC, add, and click on OK. So now we created whole 4 construction stages, and we have to define the composite section which correspond to each construction stage, because you are within composite. So actually the steel will be activated first, and the slab will be activated afterwards. So click on the composite section for CS and click on add. So active stage CS1 section 1 composite normal. So here you have the two parts, the element part 2. So here we'll choose material. Here you can choose the activated stage. Choose the material, cement, the age, and so the activate stage will be CS2. Age will be 5 days, and the last thing we have to do is to go in the stiff scale and to put the weight to 0. So it is actually to not include the self-weight of the concrete in the automatic calculation of the self-weight by the self command. So it will be defined actually by the element beam load we defined previously. This is why we input 0 here. Apply. Now do the same for the other sections. So active stage, it will be again CS1 section 2. This time, so part 1 it's the same. Part 2 material grade. Active stage, it will be CS3 this time. The age will be 0. Stiffness, and here again enter 0 for the weight. Okay, click on apply, and finally section 3 material active stage 0 and OK. Close. Now we are ready to launch the analysis. So we have to set, before beginning the analysis, we have to set the options to go into construction stages and choose the options. So last stage for the final stage. Check the include time dependent effects. So click here. Verify that creep and shrinkage are activated. So for convergence for the creep iteration, we'll put 5 and tolerance is 0.01. Then for the internal time step for the creep, activate and set it to 1. And this will check this option, auto time step generation, and click on OK. So now we are ready to launch the analysis. Okay, so come back to the construction stage, define stage, and for each construction stage you have to activate the save results option. Now let's verify again the construction stage option. Okay, and we can perform the analysis. Okay, now the analysis is over and we can review the results. So there are two methods of reviewing the analysis results for the construction stage analysis. One is to review the accumulated member forces and the displacements of all the members at each specific construction stage. and the other is to review the changes of the stresses in each part of the composite section due to the preceding construction stage in the table format. So let's review first the member forces. So actually here in this small tab you can select one precise construction stage. So you can select the stage 4, for example. You have also min and maximum and the post CS stage. So go in the results tab, and in the here go in the result tab, forces, and here you have beam diagram. So if you check that, for the load case check the CS summation and choose the last step, and you can see on the graph, so better to hide the beam load and the boundaries to see better. Okay, now you see the beam diagram. You can see the legend too, and you can check that for each construction stage. So for the first one, then the second one, third one, and the fourth. So for each construction stage you have this. If you want, you can also review the deform shape and displacement contour. So this is the bridge. You can view the deform shape like that. You can change the scale factor, and like that by each step of construction. So here you view the slab has been added, so the second stage, the third and the fourth stage you have the bridge, and finally the final stage. Now let's review the stress. So here in the results tab you have results tables, and let's go into this composite section for CS and check the beam stress. Now you have a big table and it's asking which kind of stress you want to see. So first choose an element, so we'll see the stress of the element 19. Load case combination, we'll choose the summation CS. We'll choose to see all the construction stages, and only the part G will be checked. And now you see you have all the information you need in a table. So the actual stress bending following several directions. Okay, it's all for this tutorial. So thank you very much for watching, and again, we'll have some tutorials every week, so don't forget to subscribe to the YouTube channel. Thank you.